Hello, everybody. Yeah, I'm Vittorio, and it's great to be back at Demuxed. I think last time we were here, it was 2019, which is 10 years ago, because I count each pandemic year 5 years. The pandemic was definitely an interesting time. A lot of us to pick up a lot of hobbies, and the one I picked was virtual reality. And what I'm going to present to you today is a perspective from my more familiar points of view, the open source and the multimedia and video encoding. So let's talk about VR, virtual reality. I categorize the two kinds of VR. One is the more traditional one with specialized hardware that can capture everything that happens around the camera and recreates a sphere with the special microphones capturing the audio as well. Or it can be a software-based VR system where you are in a game, in a 3D scene, and you are again in a sphere and able to interact with the environment. This has been an interesting trend of VR content being consumed. For example, this is the graphs for a popular VR application that of both streamers and the viewers. You can see there is an interesting bump around the 2020 mark for no particular reason. And so people are actually interested in consuming this kind of content. But what exactly is VR? Like, I can provide you two kinds of answer. One is the more philosophical one. It's a world of endless possibilities where you can create anything you want. It's actually interesting that this is the 40th anniversary of Tron, which is the first time that virtual reality was featured in a mainstream media. But for us multimedia engineer, virtual reality consists mostly in three points. One, you need a spatial video. Instead of using a 2D surface for your video, you use a sphere. Then you need the stereoscopy, so you need to have two different streams so that you have the depth perception. And this is what we call a 360 video. And then you need immersive audio. That is, the audio needs to be independent of the channel layout and surrounding yourself, independent of the position you are in said sphere. So how do we go from a 3D video to a 2D surface, or vice versa? I'm going to introduce you to the Spherical Video V2 RFC, which is a specification that Google, Facebook, and Vimeo engineers worked on a few years ago, and where it defines three main projection. The first one is the equirectangular projection, which is basically stretching the sphere into a 2D surface. It's very simple, very well supported. It works. There are it introduces some artifacts around the edges because of the stretching these are unavoidable. And the best solution is usually either increasing the bitrate or applying some region of interest around the edges. The main downside is that in order to get the 3D effect, we need a whole separate frame for the other eye. So it can be costly in terms of bandwidth. The other one is the cube map projection works in a way that instead of the user being in a sphere, they are in a cube, and the cube faces are then unfolded and placed on a 2D surface. This works. You can dispose the faces in any way you want, and there is a room for two different eyes. Quality gets a little bit compromised because you have more tiles than your usual frame size, but it works, and there are a lot of variations on this format. One is the equiangular cube map, which is a way to distribute the pixel differently, so that around the corners of the cube you have a better distribution of the pixel and less wasted space for compression. And the other one is the pyramid projection, which is a different way to fold the faces of the cube and moving the viewer on a different perspective. Finally, we have the mesh projection, which is a native stereo format where you consider the 2D surface as a texture. So you define polygons and the number of operations that the texture needs to operate. And you ship it that way as if it was a normal video. These are the three main categories, but it's not so simple. There is a big standardization problem. This is the V2 version of the specification. The V1 is a giant XML file based off the Google Maps API that got embedded inside the MP4, and it's a bit not nice to parse, and it creates also not nice way to tag the video because, for example, Final Cut still uses the V1 instead of the V2 specification, and YouTube uses a mix sometimes the V2 specification, and for the VR 180 it uses V2 for the image segment, but then it uses the V1 for the rest of the file. So it's a bit of a messy situation. But if you use the FFmpeg, most of this is abstracted away, and so we are good there. For audio, we are in a bit of better situation. We need a way to represent immersive audio. Immersive audio meaning something that can be some audio that can be reproduced independent of the position of the listener. There are a lot of solutions to this problem. One is object-based audio. One other one is a multitude of channels. But the one that the industry seems to prefer is the Ambisonic because it's not object-based. It's a fixed. It does not use a fixed channel layout, and it's old, so there are no patents attached to it. And you can. It's already natively supported on Opus and AAC in Ambisonic. And the specification that defines the bindings is single, so there is no backward compatibility problem. The Ambisonic system works by dividing the audio sound field into different harmonics. An audio harmonic can be explained as a direction where the sound comes from. And the amount of harmonics defines the order of the Ambisonic format. So for the 0th format, you have a single channel, which can be interpreted as the mono version of the audio and represents the intensity of the audio you're listening. And then the more orders you add, so the higher the number of channels you operate on, the more information gets added to the sound field, and the better representation of the audio sound field gets included and reconstructed. This was an interesting project. Ambisonic was very interesting because it used not to be possible to represent in FFmpeg, but as JB mentioned yesterday, a new channel layout has been introduced, we moved from having a mask-based channel system where the channel layout was a bit mask of the channel type. We moved from this system to something more complex. So it's now we have three elements. One is the AV channel, which represents the type of channel you are dealing with. The order, the AV channel order, which represents how the channel is mapped in the channel layout. And then you have the AV channel layout struct, which combines all this information and defines a map a map or a mask that defines how the channels are sorted in your system. So, for example, you can still represent the classic channel layout structure with the mask, or you can have a more complex system like Ambisonic that have a varying number of channels and can be ordered in a different way. And in the case you would use the map and be able to represent it normally in your system. Wrapping things up, there is definitely not a one-size-fits-all solution. Every major provider has deployed their own system, and I think the main takeaway is that VR is definitely still unexplored and very young, despite being a relatively old system. It's well supported in open source tools. There are both FFmpeg as Mesh and VLC all support dealing with these kind of files. And when you get familiar with VR, you also get familiar with the augmented reality, which is an important market segment for the future. On the downside, there are a couple of, I wouldn't say problem, but interesting working points. One is for sure it's a niche, but it's a very flourishing niche and expanding. The standardization effort could be better. Besides the V1, V2 idiosyncrasy, there is also like how to signal this kind of metadata in Dash and HLS. And overall, the user experience could be improved because wearing a headset is not something that people do every day. But it's something that we do, we definitely do. And it's definitely an explored territory for research purposes as well. Like, we could definitely think of a video codec that is specialized for VR content, for example. All in all, I think that this time VR is here to stay because there are users consuming the content and producing the content. And even though it's a niche, there is a market for it. And where there is a market, there is also video nearby. Thank you very much. And I can take any questions.